students. Today we will start with the combination of errors. Yesterday we discussed the types of error and how at the last absolute error, mean absolute error, and then relative error and percentage error. Today we are going to talk about combination of what errors. So combination of errors, when they combine, how they behave, either with an addition or a subtraction or a product, maybe division. First of all, I will tell you that how we write the measured quantity when we talk about the error. Say I'm giving an example. If you say the length of a room, any room, is L, maybe, okay, say 6 or 8. That means you are not sure, either it is 6 or 8. So do you know how you write it? It is written as L plus minus delta L. What will be the mean value of this? It will be 6 plus 8 by 2, that is 7. 14 by 2, 7, plus minus what? 1. So this is the way, either it may be 8 or it may be 6. So this is the way we write the measured quantity. First of all, we should know that how we write it. And remember one thing is that delta L is less than L. Delta L is small. Okay, remember, delta L is error. So error are not big, errors are very small. So today we are going to follow one by one the rule related with the error. The first rule or the first law, maybe it is related with error of sum or a difference. This is the first one. That means when they add and when they subtract, what happens to the error value. So let two physical quantities are given. Okay, मान लें there are two physical quantities. Let A and B, any two physical quantities. So measured value will be written as, do you know, measured value will be what? A plus minus delta A and B plus minus what? Delta B. Got it or not? And delta A and delta B are what? Which error? Can you tell me? They are what? Absolute errors. Already we have discussed it. So they are absolute error. Now how they behave when we sum them? So when we do Z equal to A plus B, if I write Z equal to A plus B, then you know certainly in addition, in place of Z I will write Z plus minus delta Z, A plus minus delta A, and what? B plus minus delta B. So what is the maximum? Then I can write like this also, it A plus B, then the true value will add in 1 and then plus was delta A plus delta B. Error value will add in 1. So what we see is this is the error value addition. So maximum possible error in Z is what? Can you tell me? It is delta Z what? Plus minus delta Z, or you can write directly delta Z is equal to what? Delta L plus delta B. So this is the error value in this case. And same if I want to do Z equal to A minus B, if I want to do Z equal to A minus B, you know the same thing will come. I will write Z plus minus delta Z, A plus minus delta A, and then in place of A plus minus delta A, and then in place of B, B plus minus delta B, and then if I open it, I can take the true value in 1 and the error value in 1, and then it will be plus minus delta A, and then minus plus, again it is plus minus what? Delta B. So finally I am writing A plus A minus B, and it will be plus minus what? Delta A plus delta B. Are you getting it or not? Again, if I compare it, if I see maximum possible error, you know it comes the same. Maximum possible error in Z is what? Same. Delta Z is equal to delta A plus delta B. So error of sum or difference have same rule. The error they add. So error value maximum possible error in Z is this. Now after this we'll talk about the error of sum or difference we have done. We'll talk about error of what? The product or a quotient. One thing is that error when two quantities, I'm writing here, when two quantities, remember when two quantities are added or subtracted, remember one thing, comma, the absolute error in final result, remember in final result is the sum, which we have explained is the sum of the absolute error in the individual quantities or the measured quantities. Individual quantities. This we have discussed. Okay. Now we are talking about what? Error of a product or a quotient. That means it is for division and multiplication. Same rule. Now how it is the same rule? I will just give you an example. Suppose Z is equal to AB. This is the product. And we know that the measured value, if you replace it, it will be Z plus minus delta Z and A plus minus delta A. Okay. And in place of B plus minus delta B. Are you getting it? Though we are not going to ask the proof. We'll do the numerical, then we multiply it. It will come like this. B delta A plus minus A delta B and plus minus delta A delta B. Are you getting it? Simple multiplication. And then dividing LHS by Z and RHS by AB. Same thing, we are dividing it. So do you know if you divide it by Z and it by AB, it will be coming like this. 1 plus minus delta Z by Z, 1 plus minus delta A by A, plus minus delta B by B, and then plus minus delta A by A and delta B by B. Are you getting it or not? So this you will get. And here what I said, delta A and delta B are small, very small. So we ignore their product. So these are the mathematical implications which we will later on you will go through. We ignore their product because it will become very less. So we are going to ignore this part. Remember. So finally we can write is that the rule is for maximum possible error, in Z is delta Z by Z can be written as delta A by A plus what? Delta B by B. This is the rule for what? Product. See here. What happened? This is neglected. 1 will cancel out with 1 and this will remain. This is the possible error. Then certainly this can be directly remembered as what? Do you know when Z is what? AB. We write relative error in Z is sum of relative error in A plus relative error in B. Why? Because Z is related with A and B. It's like a V equal to IR, Ohm's law. It is like power equal to VI. Power you have gone through in class 10. So these are the product. We can directly apply relative error in Z equal to relative error in A plus relative error in B plus relative error in C plus so on. And similarly, if I write Z A by B, that is the division. So again the same thing will come, that relative error in Z will be relative error in A plus relative error in B. Why? Because Z is related with A and B. So same thing comes for this. Though you can do the proof of it also, but I am writing the same thing here that is for the division also. So that means division and product, they have same way of dealing with the error. So we can write when two quantities are multiplied, okay, or divided, remember, or divided, the relative error, you have seen it, the relative error in the result is the sum of the relative errors in the quantities or multipliers. Got it or not? So this is for which? Division and product, and this is for addition and subtraction. So error of sum or difference have same concept, error of division and product have same concept. And then another important thing is that then we'll go for the numericals, that there is error in case of a measured quantity raised to power. There is another important, if there is an exponential quantity. So when we talk about the error in case of a measured quantity, okay, raised to a power. So any quantity if it is raised to a power, say there is a quantity which is written as z equal to a to the power n. It's a quantity. Suppose z is a to the power n, any quantity. Then do you know I am writing it? If I write it, then it will be delta z by z. Okay, and then the same way we are going to deal with is delta z by z will be n times what do you know? Delta a by a. So this is the rule for this. That means relative error in z will be n times relative error in a. So this is rule. Remember, whenever the quantities will come in the exponential, because n times this error is happening. So this can be written in this form. Even you can find out that how it comes, but this is the rule that how. That was the reason that in volume, when we talk about the volume 4 by 3 pi r cube, I gave you the numerical 4 by 3 pi r cube. 4 by 3 pi is okay, it's a constant. But delta v by v, the relative error in this was 3 times of what? You remember? Delta r by r. So this was similarly, if I say the surface area 4 pi r square, what will be the relative error? Delta s by s will be what? 2 times of delta r by r. So these are the examples for what? Error in case of measured raised to a power. So these are the rules. Now we can do some basic numericals on. Say the question comes in this form that the length of a table is say 2 plus minus 0.2 meter and breadth is 1 plus minus 0.1 meter. Now the question comes, find the perimeter with error value. So I think you know that perimeter is what? You know all 2L plus B. Are you getting it? So directly I can write P plus minus delta P will be what? 2 what? L plus minus delta L plus 2B plus minus delta B. So very simple. It will be 2 plus minus 0.2 plus 2, 1 plus minus 0.1. And I think it is 4 plus minus 0.4 plus 2 plus minus 0.2. So what can I write is 6 plus minus 0.6. Are you getting it or not? 2 twice of length plus breadth. So simply L plus V, 2 3 is 6 and 0.2. This will be the error. Here what is the error? value for the parameter. Zero point 0.6 is actually the delta p. So this is how we get it. And do you know, very interesting thing, if I say percentage error in parameter, okay, are you getting it or not? Percentage error, remember what it will be, delta p by p into 100. That means I will write 0.6 by 6 into 100. So that means it will be what? 0.1 into 100, that is 10%. So 10% will be the error in this case. So 6 plus minus. Got it or not? How you write the percentage error in parameter? This is one question based on the addition of the error. Now, I will give you another example. Say there is a quantity and it says that find the relative error in Z if Z is equal to a to the power, say any power is given 4, b 1 by 3, c d to the power 3 by 2. Then how you write relative error? Very simple. How you write relative error? What or not, because this is the product. So delta z by z can be written. Now this is exponential. 4 times delta a by a. This is another exponential. 1 by 3 times delta v by v. Then there is no one exponent, delta c by c. And what is there? 3 by 2. Then 3 by 2 delta d by d. So this is the way we are going to write the error on relative error. Then you can find out the percentage error. Percentage error you have to multiply by 100. Another question is there, the say temperature. The temperature of the bodies measured by thermometer, and they are given, or say one temperature is 20 plus minus 0.5 degrees Celsius and another is T2 equal to 50 plus minus 0.5 degrees Celsius. So it is writing that calculate temperature difference and the error. That is with the error therein. Okay, so I think you got it or not. This is the T2. So final temperature minus initial. So T dash is what? T2 minus T1. And I am writing directly 50 minus 20. Are you getting it? Plus minus. What will happen to this? Can anyone tell me? You know that error adds. So 0.5 plus 0.5. So 30 plus minus what? 0.5 into 1 degree Celsius. So this is the answer in this question. So in this way we can see how to deal with these questions. I can take another important question and then say the question comes, if the current reading in ammeter is I equal to 6 plus minus 0.1, 0.6 milliampere. Okay. And resistance is R equal to 5 plus minus 0.5 ohm. Then question is find percentage error in what? Voltage. Now all of you know how to find it. V is what? IR. So this is a relative error. How you are going to write it? Delta V by V equal to delta I by I plus delta R by R. So delta I is what? 0.6 by 6. Delta R is what? 0.5 by what? 5. And then you solve it. it becomes 0.1, it becomes 0.1. Are you getting it? And that is 0.2. So relative error you got 0.2. What will be the percentage error? Delta V by V into what? 100. So 0.2 into 100, that is 20%. So this is how we are going to deal with the errors, and we can find out the maximum possible error in any of the, say I am taking another question 1. There is a question that the quantity P, any physical quantity is given, any physical quantity is given by Q equal to root A B C half D 3 by 2. Okay, and percentage error in A, comma B, comma C and D are, say their percentage error, say A, say it is 2%, then B 1%, then C 4%, and D it is 6%. So find percentage error in Q. So I think you can write it. So first we have to write Q, delta Q by Q will be what? Half delta A by A. Are you getting it or not? Plus delta B by B plus half delta C by C plus 3 by 2 delta D by D, and then percentage error, you know what you do. We know delta Q by Q into what? 100 will be half delta A by A into 100, then delta B by B into 100, and then half delta C by C into 100, and then 3 by 2 delta D by D into 100. This is the way percentage error we write. So half, what is delta A by A into 100? It is 2%. Okay, then delta B by B into 100, it is 1%, and half, then delta C by, that is 4%, and then 3 by 2, and that is what? 6%. So what you got is that 1% from here plus 1% from here plus 2% from here, and 2 3 is 6, 3 3 is 9, plus 9% from here. Are you getting it or not? So 2 to 4 and 9, it is 13%. Are you getting it or not? So any physical quantity is given like this, and percent, write the relative error. See how you are going to write it. It follows what? Exponential, division, product rule. So half delta A by A, delta B by B, then C has power half delta, then D has power 3 by 2, then into 100. Why? Because they are percentage error. Then here you put what? 2%, here you put 1%, then 4%, then 6. Solve it out, you will get the answer. So these are the error which are related with the what? The combination of the errors, and then we can do further numericals on this. Okay, thank you, and do the assignments properly and regular watch my videos.